Okay guys, welcome back to our second installment of Exercise Prescription. This will be Lecture B to Exercise Prescription for Healthy Populations and Healthy Individuals. When we last left off, we were talking about exercise frequency and the FIT principle, and we're going to pick up from there today. And we're going to continue by talking more about some of those adaptations that we spoke about on the previous lecture. We did kind of discuss in detail some of the cardiorespiratory adaptations that occur when we do increase our frequency of exercise, and we have a chronic increase in frequency of exercise, which means that we're not exercising in a fair weather sort of capacity, but we're doing it continuously and intentionally. And with that change in frequency, we get the adaptations that come with it, so the physiological adaptations. So to kind of pick up on that and to continue that discussion, we're going to talk about some of the adaptations, some more adaptations that come with aerobic training. And as you can see here, lung capacity increases. So generally, all of these components that we're talking about when it comes to exercise, the more progressive we are and the more continuous we are with our exercise, the greater these capacities become. So lung capacity increases, which allows us to basically take in more air and get rid of more CO2, and allows us to supply more oxygen during maximal exercise. Hemoglobin also increases. So one of the adaptations that come with increase in our frequency of exercise is hemoglobin, and that is the substance in the blood that basically binds O2. So if we increase hemoglobin, we increase the ability to bind more oxygen to that hemoglobin. So if we think about just those two right there, the lung capacity and the hemoglobin, those two types of adaptations will have substantial changes on VO2 max and VO2 max scores. Also, we get muscle hypertrophy, so we get an increase in size of the muscle. Generally, when we get an increase of size in the muscle, we also get increased capillary density, because if the muscle gets bigger, we have to be able to deliver more nutrients and more oxygen to that muscle. So we'll get more capillaries. And generally, when we're dealing with aerobic training, we also get more mitochondria. And the mitochondria that we do have, it functions better. So it increases its capacity to metabolize fatty acids and oxygen, and all of the enzymes that are in the mitochondria operate more effectively as well. So we have all these things that change with increases in frequency of exercise. Now, some of these are short-term adaptations. There are some more long-term adaptations that will occur. And what I mean by that is the longer we do it, the greater adaptations that occur. So, but we generally need to be into like 2, 3, 4 months of exercise before these type of adaptations occur, because we're going to have some structural changes that can happen with the heart that will also increase our capacity to exercise. And on the next slide here, I have a picture of some hearts and this phenomenon that happens called athlete's heart. And basically, athlete's heart is not a medical condition. It's described as kind of normal changes that occur in the heart of an individual who is participating in intense athletic training. So the changes are subtle, but they do occur, and they include small increases in the size of the pumping chamber, right, which would be the left ventricle and the right ventricle, and also changes in the filling chamber, which would be the atrium, right? So we get this increase in both in sizes. So we have these structural changes in the heart where the ventricles and the atrium can become slightly bigger, right? Now, this adaptation happens over a long period of time because the body has to make sure that the exercise stimulus is constant before it starts to restructure the muscles surrounding the heart, right? Because if it's not exercise that's inducing that type of change, such structural changes can be really dangerous to the heart. So this takes a little bit more time. These changes are believed to be adaptive, so they're happening because we're exercising. and they reflect positive changes in the heart that allow people to increase blood supply and increase oxygen to exercising tissue, okay? So basically what we'll see here is here we have a normal heart, and you can see the ventricle and the atrium, right? Or the atriums and the ventricle. And then here we have an enlarged heart. This would be the athlete's heart, where you can clearly see that the atriums and the ventricles become a little bigger in size, right? So we have this complex structural change, and because the structural change is occurring, we have a functional change, okay? So this is remodeling, okay? Now, this type of change also happens in pathogenic states where we get a heart that looks like this, right? So we get the muscles surrounding the heart where they get so large, but that's generally due to total peripheral resistance. So if we're in a state where we're living with a chronic disease and our vascular system is compromised, right? We're building that plaque that we were talking about. Well, that's going to build resistance and pressure in the vascular system, which means the heart is going to have to pump harder to get that blood circulating. So one of the adaptations that come from pathology is as that heart pumps harder, the muscles around the heart become bigger, right? But if you can see here in an athlete's heart, the chambers become slightly larger and the muscles become slightly larger as well, right? If we look at a normal heart, we can see that the muscles surrounding the heart here have become bigger. But in this state here, we have an increase in chamber and an increase in muscle, right? So it makes this more functional. Where if we look at a diseased heart, we have a decrease in chamber size and an increase in muscle, right? So this means far less blood can be pumped into these specific chambers within the heart, okay? So, and you can see here that we have some changes in the heart, right? So this would be a normal heart, and we can have these favorable adaptations that occur through exercise where the heart ventricle, this would be that area here, gets slightly bigger and therefore more capable of pumping oxygenated blood out to the working muscles. All right. So we can look at some different types of changes that can happen based upon stimuli. So some of this cardiac remodeling here can occur in different types of scenarios. So we can have eccentric left ventricle hypertrophy, right? And this is a cardiac remodeling that occurs in endurance athletes. And if you think about it, if you think about what endurance athletes need to be considered endurance athletes, right? If we go back to that VO2 thing that we've been talking a lot about, VO2 is most dependent on stroke volume, and stroke volume is most dependent on what happens in the left ventricle, right? So when we get left ventricle hypertrophy, you can see that the muscles surrounding the left ventricle become larger, right? So here would be a sedentary heart, and we can see that there's no changes in the muscles surrounding the ventricle. Here we can see that in a endurance athlete, we have left ventricle hypertrophy where these muscles are slightly bigger. Now, when we have an athlete like a soccer player or a baseball player, right, that kind of goes in between a strength athlete and an endurance athlete, you can see that this left ventricle hypertrophy is balanced, right? We have kind of just a balanced representation of muscles surrounding both the left and the right ventricle. Now, when we get into strength athletes, we can see that we have a concentric left ventricle hypertrophy, okay? And this is what occurs in strength athletes specifically, okay? So in left ventricle hypertrophy, this is a form of cardiac remodeling that causes the heart muscle wall to thicken, which leads into basically an increase in left ventricle mass. And because of that left ventricle mass, that left ventricle is now capable of contracting more effectively and ejecting more blood out into the bloodstream, okay? And these morphological changes really depend on the kind of training that an individual is undergoing. So again, endurance training is associated with an increase in cardiac output, right? And this left ventricle hypertrophy, this eccentric left ventricle hypertrophy is more favorable to that cardiac output. And it causes endurance trained hearts to generate more moderate dilation of the left ventricle combined with an increase in the left ventricle wall thickness, which means that the left ventricle can take in more blood and shoot more blood out, okay? And since we're talking about aerobic training, we're just going to kind of focus on this remodeling here, all right? So let's move on a little bit. Now, if we want to talk about adaptations that occur in fibers, right? We talked about skeletal muscle fibers in our previous lecture. Aerobic training, obviously those are going to be your type 1 slow twitch fibers, right? Some of the adaptations that come are increase in capillary density and capillary supply. So we talked about that, right? And that basically improves the delivery of oxygen and the movement of nutrients such as glucose, right? We know that contracting muscles are going to need glucose, but also it removes waste products. So we're going to have a removal of CO2 and metabolites that are coming from the contracting muscle. I already talked about this. We have an increase in the size and the density of mitochondria, okay? And then we have an increase in myoglobin content, okay? And that's basically what transports oxygen from the cell membrane to the mitochondria. So we get more of these transporters, this myoglobin, and type 1 fibers are very rich with myoglobin, and that's why type 1 fibers look very red under a microscope, because myoglobin carries this red hue with it. Now, if we look at changes in fast twitch fibers, we have an increased capacity to use our ATP and PC supply, increase in glycolytic enzymes, right? So the more we exercise, the more frequent the exercise, the more of those glycolytic enzymes we get, and they improve their function. So we're talking about like those glycolytic enzymes like phosphofructose kinase. They become more sensitive to the needs of the muscle. They function more effectively, and we also upregulate more of them, so we can handle more glucose flux coming into the cell, okay? We increase our tolerance for lactic acid, which means that we increase our ability to buffer it and basically utilize it as a secondary fuel source. And these are some of the most important things that happen to the fibers. So not just the heart, but the contracting fibers when we exercise and we increase our exercise frequency. Now, if we stop exercising and we no longer are frequently doing it, right? We're doing it once a week, twice a week. It becomes more fair weather. Then what happens is all those adaptations disappear. So if we look at this graph here, we can look at percent change on the left. And on the bottom, we're looking at days of detraining. And here we can see all these markers of fitness, right? So we see VO2 max, heart rate max, stroke volume max, okay, cardiac output max. And here we have the arterial venous difference of oxygen saturation. So after a couple of days of detraining, right? So like let's say we stop exercising for roughly 12 days, all right? You can see that there's an immediate plunge in VO2, cardiac output, and there it is, most importantly, stroke volume, okay? So that tells us that some of the first changes that occur with detraining are occurring in the heart, right? And what's interesting is if we look at heart rate, as these modifications that we've gained through exercise, if they decrease, the heart begins working harder, right? So we have a 5% increase in heart rate max. So the heart starts working harder. And you can also see here that our AVO2 difference changes. Now we have more oxygen in the venous side, right, coming back. So that means that we have less oxygen being delivered at the skeletal muscle. And you can see that these things all kind of fluctuate and change as we get into 21 days. We have a further drop in heart function and heart remodeling. So we have VO2 dropping again. we have stroke volume dropping, and we have cardiac output dropping. And if you look at VO2, it just kind of keeps plummeting. Okay, so after 56 days of detraining, 84 days of detraining, we could have a 20% loss of VO2 max. And we can see that there's an inverse relationship between VO2 and heart rate, because heart rate just keeps going up. Okay, so it doesn't take very long to lose everything that we have gained. Okay, so now let's move into frequency with a little more depth. Okay, so when we're considering frequency of exercise, we have to consider if we're talking about aerobic training or strength training. So something that's really important for you guys to understand from this point on is that frequency, intensity, duration, all of these variables we're going to talk about, they're all related to one another. Okay, so if we change one, if we change duration, then that's going to directly change frequency and intensity, right? So they're all interrelated. If you change intensity, that's going to have an impact on how frequently you conduct an exercise and what the duration of time that exercise is going to be. So, one of the things that we're trying to do, right? The whole reason we're training is because when we have this stimulus are going to tell the skeletal muscle cells to do a certain thing, right? To undergo a certain adaptation. And if we exercise train, these adaptations are going to be completely then different than strength training adaptations. Okay, so they can shut one another off. If we look at PCG1 alpha here, when we do aerobic training, we have this cascade of cellular signals that occur, and aerobic training is going to tell the muscle to activate this transcription factor, PCG1 alpha. And PCG1 alpha is going to bind to the DNA, and it's going to transcribe and tell the mitochondria to create more of itself. And generally, when we activate PCG1 alpha, or we activate this aerobic pathway, it tells the strength pathway to shut off, right? Because when we do strength training, we activate PI3K, we activate AKT, AKT activates mTOR, mTOR basically activates these proteins and allows protein synthesis, which we see here, and protein degradation to occur, right? And if we're having protein synthesis, that's making the muscle get bigger. So these two signals shut one another off. Okay, so keep that in mind. So we have to be very specific in our approach to exercise. So when we're talking about frequency, let's answer this question here. If an individual wants to exercise from a vigorous perspective, they want to do it 5 or more days a week, what can that individual do to decrease risk of injury? So we know that the more frequently we exercise, the more susceptible we are to injury. So can an individual successfully exercise for 5 to 6 days a week? And this is something, there's a couple of questions you have to ask yourself. Well, who is that individual? What is their current workout regimen? Are they identifying when they have days off? Because if you're working 5 to 6 days a week and you only have 1 day off, that's going to be problematic, because we know that most research out there shows that if you over-exercise, you become more susceptible to injury and illness, and you weaken your immune system. So there's a tremendous amount of data out there that says you can overdo it. Now, that's not to say you can't exercise 5 or 6 or 7 days a week, but if you do it, you got to do a couple of different things. One is you have to use a variety of different exercise modes. Okay, so if you're exercising 5 to 6 days a week, if you're doing strength training 3 days a week and aerobic training 2 days a week, then you could probably successfully do that and still obtain the adaptations that you desire. Okay, if you are exercising, doing HIIT training 5 to 6 days a week, and this is where a lot of the CrossFitters run into problems, and this is why CrossFit gets such a bad such a bad rep, that is going to be detrimental to the body, because you are repeating the exact same motions, the exact same movements. You are activating the same metabolic pathways, and you are doing that 5 to 6 days a week. And you are also practicing poor dietary habits on top of that, because CrossFit generally follows the caveman diet or the carnivore diet or the paleo diet, where they choose not to replenish their body with any of the necessary carbohydrates that should be fueling the exercise. That's why the CrossFitters look so lean and so ripped, is because they're in a constant state of catabolism, because their muscle protein is consuming itself, and probably most of them are in ketosis. So if we change the variety and the modality of exercise, we can successfully do 5 to 6 days a week. If we place different stresses on the body, then that would help us do so. So for example, if we were doing strength training 2-3 days a week, and we chose to ride a bike 3 days a week, that's placing different stresses on the body. So strength training is putting a lot of heavy weight on the body. It's put a lot of pressure on the body. And then when you cycle, that is a non-load bearing activity. So now you are still exercising, but there is no additional load being placed on the body in the same fashion that we would see during strength training. Okay, so yeah, you can do it if you approach it intelligently. And then again, most importantly is different muscle groups. Some individuals, when they work out 4 days a week, and they do whole body workouts where they're purposely activating every muscle group and stressing every muscle group. That's not a bad approach if you're doing it 3 days a week and you're giving plenty of time in between to recover those muscle groups, 24 to 48 hours. But if you wanted to strength train, let's say 5 days a week, and you successfully broke down those strength training regimens into different muscle groups and subgroups, then you could do it without worrying about receiving injury. Okay, so there are ways around exercising 2-3 days a week where we can do it safely. Now, if someone exercises once or twice a week, does that provide the same benefits as 5 days a week or 3 days a week? And there's a lot of different opinions out there about this. It can, but it has to be high volume, which means the intensity has to increase. So if we're talking about frequency, and I told you a lot of these are interrelated, if we're talking about frequency, we have to consider intensity. So if you want to exercise 1 or 2 days a week and you want the same benefits, the intensity has to be much higher. If you want to exercise 3 days a week instead of 2 days a week, you can reduce the intensity. If you want to exercise 5 days a week, the intensity has to be much lower. And again, that's going back to the problem with the CrossFit groups or the CrossFit subculture out there. They exercise at high intensity 5 days a week, which is why injury rates are so high in those populations. And one thing you have to consider, especially with ACSM, is they don't recommend high intensity workouts, because ACSM focuses on health fitness, right? So they focus on a group of people that are not considered athletic, right? They're not considered athletes. With athletes, you can press that intensity, right? You can do a lot of volume in 2 short days. But with fair weather people that aren't athletes, people that exercise once in a while, this type of approach becomes dangerous because it risks injury with fair weather practitioners, okay? And the risk of cardiovascular episodes also becomes greater in health populations because their heart is not used to being pressured at a high intensity workout like that. So some things you have to consider, and this is where it's really important for you to understand who it is you're working with, which group of people you're working with, and just how far you can push them, okay? Now, here is some ACSM frequency suggestions, okay? And I broke down 2 of them here for you, cardiorespiratory and resistance. And keep in mind that, when we spoke earlier in our first lecture, we talked about flexibility training, we talked about endurance training, we talked about neuromuscular training. So I'm just presenting the 2 basic exercises for you. And the reason being is because these things all become puzzle pieces. They all become variables that you as a trainer must figure out how to manipulate to get the product you want. Okay, so you need to know how and when to implement flexibility training for the individual that you're working with. And there is no one size fits all. You have to understand the sport that they're involved in. You have to understand the benefits that they need to obtain from working with you. And you have to understand how to get them from point A to point Z safely through your protocol or through your regiments, okay? And this is where it takes a little bit of experience working with athletes or working with people in the gym, where you'll get to kind of hone your skills, which is why we send you guys out on your internships, where you can take this information and now start building a toolbox based upon the information you have from school and on the information that you get, the hands-on experience that you get during your internship. So let's take a look at this. So cardiorespiratory fitness. So exercise. Adults should get at least 150 minutes, right? So now we're talking about duration of moderate intensity exercise per week. Okay, so in this sentence, we have duration and intensity. And this is why I'm telling you, you have to keep this in mind, because duration and intensity are going to directly impact frequency. So let's move here. If we do 30 to 60 minutes of moderate intensity exercise, then we can do 5 days per week, right? So if we have intensity and duration low, we can do frequency high. If we do 20 to 60 minutes of vigorous intensity exercise, then we have 2 to 3 days per week, okay? So if intensity goes up, frequency has to go down. Now, some people will do this approach where they have one continuous session, right? So in one session, they'll do 150 minutes, okay? And other people will do multiple shorter sessions. So instead of 3-5 days a week, they can break this, they can break these small sessions up over the course of 2 days, right? So they can do 10-minute sessions in order to reach this 150 minutes, right? So it's all up to you how you plan to put these pieces together. And again, that's dependent on the athlete or the individual you're working for or with, the goals that you have and how you plan to achieve those goals. So when we do resistance training, frequency should be 2 to 3 days a week, okay? And again, if you're doing heavy weight, high intensity, low weight, lower intensity, let me ask you this. Can intensity be both in weight and in volume? And what I mean by volume is rep range. So can intensity be considered very, very heavy weight, or can high intensity also be considered a lot of reps? And your answer should be yes. Both of those are 2 different types of intensity. So if you have somebody do 5 reps at low weight, that's not intense. If you have somebody do 5 reps at very heavy weight, that might be high intensity. If you have somebody do 30 reps at low weight, that will be high intensity, because now you're challenging their endurance capacity, and the volume of reps changes the intensity. So I hope you guys understand that. I hope I explained that clearly enough for you. So now let's talk about intensity. We're leaving frequency and we're getting into intensity. So with intensity, there is a positive dose-response relationship, okay? So as intensity goes up, mortality risk goes down. As intensity goes up, performance goes up. As intensity goes up, athleticism goes up. As intensity goes up, health goes up, okay? So when we're dealing with intensity, there is the bigger the dose, the bigger the response, okay? And the better the response, okay? So we call this a dose-dependent response. If we have low intensity, we have a poor response. If we have high intensity, we have a better response, okay? And here it is in blue. Greater health benefits from increasing intensity. So there is a minimum threshold to improve cardiorespiratory fitness, okay? And basically, this threshold is difficult to define, and it's very specific to an individual, all right? So when we're talking about intensity, we have to understand where somebody's basement is and where their ceiling is, okay? And this is why we do VO2 max testing, right? If we do a VO2 max test to measure their maximum oxygen uptake, and we do a maximal effort test, then we're measuring their ceiling. We're measuring how high and how hard we can push them. Now, if we want to know what their basement is, right, we have to look at their resting metabolic rate. So that would be where we do indirect calorimetry. We lay them down and we measure oxygen and gas exchange, and we determine what their resting VO2 is. Okay? And now we know the area that we have to work, the difference, right, between resting and maximum VO2. We know the area that we can work in order to get the maximum VO2 higher. Okay? So one of the things we have to think about when we're working with cardiorespiratory fitness and intensity is we have to consider their current level of fitness. And we can do that through observational studies. We can do that through directly measuring. We could do it through absolute intensity values or relative intensity values. Okay, this will give us information on how we can determine their level of fitness. Age, health status, and individual physiology. We have to understand how these things play a role in their cardiorespiratory fitness. Right, we know that as we get older, our VO2 is naturally going to drop. We have a percentage decline. With every 10 years we get older, we have a percentage decline in VO2. If we are in poor health, we are going to have a very low VO2 score, right? 20, 30 milliliters per kilogram per body weight, right? Those are poor scores. And individual physiology, it may come down to heart. Your heart is your motor, right? So let's talk about motors for a second. If you are driving a 2-cylinder electronic car, right? Like the Toyota cars, those ones that are electronic. I can't think of the name right now, right? That is a very small engine, and it's a small engine that runs on some gas and some electricity, right? Now, if you are one of these pickup trucks that you see driving around Humboldt with the giant tires on it, and you have an 8-cylinder huge gas guzzling engine in that truck, well, obviously that's a bigger engine than the Toyota. So if we look at individual physiology, some people have bigger hearts, some people have smaller hearts, and that physiology is going to change cardiorespiratory fitness. Okay, that's going to change how we train people. That's going to change our measurements. It's going to change everything. So these are some factors that we have to keep in mind. And the last one would be physical activity history. So do we have someone that's been a lifelong athlete, or do we have somebody that is exercising for the first time? These are more considerations that we have to keep in mind when we're using this FIT principle to prescribe exercise. So let's talk a little bit about absolute intensity. Absolute intensity is a general measurement of intensity. And basically it measures different forms of energy or energy usage. Okay, so these would be things that we can do in the lab to get direct measurements of intensity. And also prescribe direct measures of intensity, right? So if we do a VO2 max test and we measure how well their body performs at different intensities, which is why we increase the grade of the treadmill, then we can get a measurement of how well they perform over the course of 7 to 8 minutes and how well they perform at different intensities. We can measure lactic threshold, we can measure CO2 output, we can measure O2 uptake, we can measure respiratory exchange ratios. These are absolute values that tell us what they're doing at certain levels of intensity. And we can do methods of estimating absolute intensity of exercise, right? So we can do direct measurements or we can do estimations of these measurements. So some of these would be caloric expenditure. So when we are doing a VO2 max, we are looking at how many calories they're expending. We can use watches, right? Fitness watches to measure how many calories are being expended during a certain type of exercise, right? And we would understand that as we increase intensity, we would have an increase in caloric expenditure, right? You guys understand that. So higher intensity, higher expenditure of calories, lower intensity, lower expenditure of calories. We can take absolute oxygen consumption. So we can look at VO2 max, and we can look at METs, right? The metabolic equivalents. So these are ways that we can get absolute measurements of intensity. And we can also prescribe absolute measurements of intensity, right? So if we have a certain caloric range that we want to have somebody work at, because it's going to be a high intensity exercise, and we can say, okay, we're going to monitor you until you reach 500 calories. So we can use calories and calorie expenditure as a modality to prescribe intensity. Same thing with METs. If we say, hey, we want you to operate for 30 minutes at 7 METs. 7 METs is pretty high intensity. Then we can use METs as a prescription as well, and not just a means of measuring intensity. So we also have relative intensity. Okay, so relative intensity is basically specific to your level of fitness, and this is the type of assessment and prescription we should use when we're working in the gym, right? We're not working with athletes, but we're working with just regular people, ACSM, health, fitness, and that population that just wants to stay healthy. This is more of the approach that we would want to take when we're thinking about intensity. So when we're looking at relative intensity, it's just like relative VO2, right? It's relative to you and your body. It's relative exercise intensity based upon your own maximum capacity of work. For example, a percentage of your maximum heart rate. So if we know how to do age predicted maximum heart rate, we can prescribe a percent of that, right? If we prescribe 90% of your maximum heart rate, we can assume that that is pretty high intensity. If we prescribe 50% of your maximum heart rate, that is low intensity. If we do 60 to 85% of your maximum heart rate, that is moderate intensity. So do you guys understand that? We could also do maximum oxygen uptake. So if we say we want to prescribe 70% of your maximal VO2, then we can use that as a way to prescribe intensity. Or if we want to do 90% of your VO2 max, we can use that to prescribe intensity. Or we can use both of them. We can use them interchangeably. So most importantly, when we're talking about relative intensity, it's specific to the individual, and it can be tailored to enhance their health and their wellness. Okay? So heart rate reserve, this is something that we've talked about in the lab, and I'm just going to kind of revisit this because we can use heart rate reserve as a way to prescribe intensity, right? And to prescribe certain intensities to different people, different populations. So what is heart rate reserve? Well, when we do heart rate reserve, we are looking at the difference between our resting heart rate and our maximum heart rate, right? And that is our heart rate reserve. So I'm 43. So in order for me to get my maximum heart rate, my age predicted maximum heart rate, I'm going to take 220 minus my age, and that gives me 177, which is my maximum heart rate. So 177 beats per minute. Okay. My resting heart rate is 55 beats per minute. So I just checked on my iWatch and it said that I'm at 55 beats per minute. And in order for me to get my my heart rate reserve, I'm going to take this, my maximum heart rate minus my resting heart rate. Here's that equation. And my heart rate reserve is going to be 122 beats per minute. Okay, now I can use this heart rate reserve to prescribe intensity, and I'm going to show you guys in a moment. So if we want to work at 70% of my heart rate reserve, we have this calculation here, which is my heart rate reserve times 0.07, right? That's 70%, plus my resting heart rate. And that will give me a target heart range to work at for intensity. If I wanted to increase that intensity, I would take my heart rate reserve, times it by 85%, right? 85% plus my resting heart rate. And that would give me an increased heart rate or a target heart range for me to work at for a different intensity. So if we look at this, right? My heart rate reserve was 122 beats per minute times 0.07 plus my resting heart rate, which gives me 140 beats per minute, okay? So this would be moderate exercise, moderate intensity. If I took that same equation, 122 times 0.85 plus my resting heart rate, you can see that that increases it 19 beats per minute, and now I'm getting closer to more vigorous and high intensity exercise. All right, so these are quick things that you can do to calculate intensity and to prescribe intensity without having any tools or any laboratory equipment with you. So if you're out on the field with a soccer team and you have different people who are playing on different positions, and you want to base an exercise that is position specific, which means you're going to have different intensities for different positions, then you can quickly run these calculations. And you can have a exercise that is using a scientific principle to guide intensity, all right, or to prescribe intensity. Here is just a couple of different equations that you can use to calculate maximum heart rate. So, here's the one that I just did, the Fox et al., right? Heart rate equals 220 minus age. Astran is slightly different. We have some slightly different variations here. So and you can see here the populations that these were used within. So this is something you can look at and just kind of mull over on your own. You might need to know it for one of the practicals coming up. So definitely make sure you understand these. But again, on the practicals, we allow you to use the textbook. So if we were to say, calculate the maximum heart rate using the Astran equation, then you would know how to do this and just kind of plug that information in here, okay? So just know where that page is and make sure you identify that page. So now we can do the same thing with VO2 and VO2 scores as we did with the heart rate reserve, okay? So we can do something called the VO2 reserve, which you guys are familiar with because I know you guys took exams on them. So a VO2 reserve is the increment in oxygen consumption a person can achieve during exercise, okay? And basically that is VO2 max minus VO2 at rest, right? So very similar to heart rate reserve. We can prescribe intensity of exercise as a percentage of VO2 reserve, just like we did with the heart rate, right? So if we have VO2 data and we have a max and we have a rest value, we can calculate reserve, and with that reserve, we can then prescribe different levels of intensity, right? I can take that reserve and multiply it by 0.7, which would be 70%. Do I want to increase the intensity, then take it up to 85? Is it somebody who is at risk? If they're at risk, I would want to drop that percentage down to 50, right? Rather than 85 or 70, that's too high. So you would essentially do the same type of calculation, VO2 max minus VO2 at rest, times whatever percent of intensity you want them to work at, and then you would add VO2 rest again, right? And this would give us a target range for us to work in at a specific intensity. So if we look at here, VO2, right? If we look at someone that is really high, right? Someone that is really high on the VO2, and that, keep in mind, this is liters per minute. This isn't liters per kilogram. And we look at somebody really low, right? We want to operate somewhere within what's too high, right? Too hard, and what's too easy, right? This is too easy. This is too hard. So by using these calculations, if we have this information, we can plot an individual somewhere in between something that's too light and something that's too severe. And we can find that just right zone, right? Based upon their specific physiology, all right? So we can do percentages of heart rate max. We can do percentages of VO2 max. We can do percentages of METs. We can do percentages of VO2 reserve. All right, so there's all these different ways that we can prescribe intensity of exercise. So when we're done with all the nuts and bolts of everything that I just explained, here's what ACSM basically tells us that we should be doing. So if we want light exercise is considered to be between 30 and 40% of heart rate reserve or VO2 reserve. If we want moderate exercise is considered between 40 and 60, right, of heart rate reserve or VO2 reserve. If we want vigorous exercise, that is considered to be between 60% and 90% of heart rate reserve or VO2 reserve. So based upon those calculations I just showed you, if we were working with a group of sprinters and they were college level sprinters and we wanted to have a pretty tough day on the field. So when we work with MMA fighters, we have brain days and we have brawn days. And brain days are where we're teaching strategy, we're teaching different combinations. We know that they're focused on everything we're saying, they're tuned in, they clocked in. Now, if there's a day where they're not listening, it turns into a brawn day, which means we just destroy the body in every way we can. So if we're doing a brain day where we want to have more conversation, more strategy, more technique, we go light, right? If we want to have a brawn day, we go heavy. And you guys can do the same thing when you're prescribing intensity of exercise. So, and keep in mind that when we operate in this area for too long of a period, if we're constantly here and we're not fluctuating between these different intensities, this becomes very beneficial for deconditioning, okay, or becoming deconditioned. So keep in mind that when we are prescribing intensity, if we are starting here, we want to eventually be able to make it here and then here, right? That is the goal, is to increase intensity, because intensity has a positive dose response with performance and health, all right? So here is a table in your ACSN manual, and this kind of basically summarizes what we were talking about with relative intensity and absolute intensity. So you can see here how they identify light, moderate, vigorous, and very light based upon heart rate reserve percentages or VO2 reserve percentages, okay? So anything between 30 to 39% of your heart rate reserve or your VO2 reserve is considered light. Again, moderate, vigorous, right? Very similar to the numbers I showed you earlier. Heart rate max, right? If you did your heart rate max calculation, 220 minus your age, anything less than 57% of that is considered very light. When we go down, same sort of thing. Vigorous exercise would be 77 to 95% of your calculated heart rate max. Same thing with the VO2, okay? Then we have the introduction of METs and VO2. So if you're operating at 20 METs and a certain percentage of your VO2, 10 METs, certain percentage of your VO2, 5 METs, certain percentage of your VO2, they give you all these values here of basically what is considered light, moderate, and vigorous. So while you're doing your readings, take some time and look at this and make sure you understand this. And if this is something that is kind of confusing to you, then please email myself or Lucas and we'll explain it to you. And then we have these absolute intensity values by MET and by age. Okay, so you can see the age range for individuals. So just kind of go over this and see if you guys can you fully understand that. And if not, just email us and we can certainly help you navigate through this if there's something that you don't understand once you've read it. Here's some more equations, methods for prescribing exercise intensity using heart rate, oxygen uptake, metabolic equivalent. So a lot of these we kind of talked about already. And again, take some time and go through this. Okay, so this is something we just talked about, right? You just saw these equations. I just went through this with you. Take a look at this, make sure you understand that, right? The VO2 method, right? Target VO2 equals VO2 peak, right? We just talked about that. And go over this, see if you understand it. If not, we will clarify it in class. We'll clarify it through email, or we can do a separate video where we can go through all of these individually if there's something you don't understand. And there are some other kind of less efficient manners of measuring intensity, and these are what we would do in the field, right? So these would be kind of like field tests per se, that we would basically ask in the field to determine somebody's intensity, if they're what rate of intensity they're working at. So Borgs rate of perceived exertion, the OMNI scale, the talk test, and the feeling scale. Okay, so let's just look at these really briefly. You guys have seen these before. We have the Borg scale and we have the modified Borg scale, and basically we have a value from 6 to 20. Okay, so if we're within the 6 to 11, that means that the intensity of the exercise is not very high, right? So if we're working with somebody, we say, hey, what's your RPE? They say, oh, I'm at a 10, then that means this is really easy. If we say I'm at a 19, this is very, very hard, right? We have all these values in the middle. And then we have the modified Borg scale, which is 0 through 10. So it's essentially the same thing, just less values. So the original Borg scale was designed to basically add a 0 to every value you see here. So let me give you an example. So the original Borg scale, if I have a 6 and I add a 0, that means that I have a heart rate of 60 beats per minute, and we know that that is not very intense. Now, if I get into this green range here and I have a 12, and let's say I add a 0, now I have a heart rate of 120 beats per minute. Okay, so that means my heart is working moderately. If I get over here to 18, and I add a 0, then this 18 is representative of 180 beats per minute, which means that now I'm in this red zone, which means that my heart is working pretty hard. Okay, and if I'm at a 20 and I add a 0, that's 200 beats per minute. And for a lot of people out there, that is maximum heart rate. And of course, that is very, very hard. So that's the difference between the modified and the original, is that the original was designed from this 6 to 20 to essentially add a 0, which represents beats per minute of the heart. The next one would be the OMNI scale of perceived exertion, very, very similar, 0 to 10, okay, 10 being the hardest and 0 being extremely easy. And are we somewhere in the middle here, right? So very much like Borgs. And this would be where you ask the person that you're working with, what's your perceived exertion? And if they say, I'm at a 4, and you want them to be working at a higher intensity, then you tell them you want to increase the intensity of the activity you're doing and get them to be somewhere up here, right? So that's how we change intensity in real time. So if they're on a treadmill and you have them running at 7 miles per hour and they're saying, okay, I'm still at a 4, then you can do two things. You can increase their speed, or you can increase the grade of the treadmill, or you can do both. So you are purposely changing their environment to increase the intensity. Talk test. This is something that a lot of people are using nowadays. Essentially what it's doing is if you want to establish moderate intensity, you talk to people. You talk to them while they're exercising. And basically you want them to be able to respond to your questions, right, in full sentences in a comfortable manner. So if you're asking them questions and they're responding, then that means that you're keeping them within a moderate intensity. All right, so that's the talk test. Now, if somebody has asked, can you still speak comfortably? And they say yes, then that means that they are under that moderate intensity. If you ask them that question and they say maybe, and they give you this ambiguous answer, that tells you that you're kind of right at that sweet spot of moderate intensity exercise. If you ask them a question and they say no, that means that you've moved past a moderate intensity and now you are at a higher intensity. So just by talking to them while you're working out, so if somebody's on a treadmill and you start talking to them, and they're incapable of responding to you, then that might mean that you've moved out of this moderate intensity range and it's just the intensity is too high. So if they're on the treadmill, slow the speed down or bring the grade of the treadmill back down. Or if you ask them a question and they're talking your ear off, that means that they're under this moderate intensity And that means you have to increase the intensity to get them where you want to be. So this is a real easy way to kind of check on how well they're doing while you're in the field with whoever it is you're working with. And then there's the feeling scale, because we all have feelings, and it's good to feel. It's nice to have feelings. Very similar to the Borgs perceived exertion, very similar to the OMNI test. Okay, you can figure that out. That's a pretty easy one. So now let's talk a bit about duration. And duration, again, is very closely related to frequency and intensity. Now, duration deals with the amount of time that we undergo physical activity or exercises performed. So are we there for 60 minutes, 30 minutes, 50 minutes? What time frame are we there? Okay, so frequency is how many days a week. Intensity is how hard is our body working, whether it's our cardiorespiratory system or our heart, or the load being placed on our muscles because we're weightlifting. That would be intensity. There's a lot of different flavors with intensity, okay? Now we're talking about duration. So how long are we doing these exercises? The recommendation of duration for most adults is 30 to 60 minutes a day of moderate intensity exercise. And again, here we go back to 150 minutes a week, okay? So we want to take this golden number here, 150 minutes a week, and we want to break that up over the course of the week, okay? So normally 30 to 60 minutes a day. Most research has shown that that has had the most beneficial effects on increasing performance and fighting off disease, okay? When we go over that, we start to run risk of overtraining, okay? Or we can do 20 to 60 minutes of vigorous exercise, and that would be greater than 75 minutes per week, okay? So greater or equal to 75 days a week. So you can see that if we increase the vigor or the intensity, we can decrease the time frame, okay? It's only by 10 minutes, but if you're going to do this here, then they recommend that you're kind of staying around that 75 minutes per week rather than 150 minutes per week, okay? So that's an example, again, of how duration and frequency and intensity are all intertwined. Or the best thing you can do to get the best results is to have these all just kind of interchangeable, have a combination. So, you should be doing moderate and vigorous exercise throughout the week. You should be doing different variations of exercise throughout the week. When it comes to weight management specifically, okay, so if we're talking now with people that are obese or diabetic or dealing with a chronic disease or a chronic illness, the longer the duration, the better the results, okay? So if we're dealing with weight management, we want to really decrease that intensity and we want to increase the duration, okay? So you see how it's almost like a recipe, like we're cooking something and we have to add certain ingredients and limit certain ingredients. Like, imagine like intensity in this case is salt, right? We don't want a lot of salt in the food, so we have to remove or cut back a little bit on that intensity because we have a different population of people and we want to increase that time frame. And by increasing that time frame, we have to drop the intensity. And this is important for individuals that have lived a long sedentary lifestyle. So remember what I said before, earlier in this presentation, I said that what was their physical activity history? How long have they been sedentary? How long have they been lifelong athletes? Have they been fair weather athletes? All of this is important. So if we have individuals that have been fair weather or have lived a sedentary lifestyle, a lot of sedentary time, we want to decrease that intensity and increase the duration. Okay, and we're going to talk about why in a second here. Most importantly for weight loss, if you look at this graph here, we have fat utilization, which is represented in the blue dots, and carbohydrate utilization, which is represented in these kind of maroon squares. Fat or carbohydrate metabolism on the left, and then on the bottom here, exercise time. So it makes sense that the longer we're exercising, right? And if we want to increase duration, we have to decrease intensity. So the longer we're exercising, The more the duration, if you look here, after 20 minutes, we just keep increasing fat utilization, right? And if we're talking about weight management, we're talking about losing weight, we want to increase lipolysis. We want to increase the breakdown of stored fats, and we want to get those fats mobilized to the working muscle so that we can metabolize them and get rid of them. So if we increase that duration, you can see that our fat utilization increases up to almost 10, 12, 13%, okay? So, and we can see that carbohydrate utilization drops because what happens is we are leaving this anaerobic metabolism, right? We're not training in the anaerobic system, so we start to limit our carbohydrate utilization, and we start to limit our aerobic glycolysis carbohydrate utilization, and we get this really robust use of fat, all right? So keep that in mind. Now, with duration, one of the questions that have been asked for a long time is, do we do continuous exercise or do we do intermittent exercise? So if we're working out for an hour, do we want to do nonstop working out or workout for nonstop, which would be continuous, or do we want to do 20 minutes, take a break, do another 20 minutes, take a break, do another 20 minutes and take a break? That would be intermittent exercise. So what research has shown is that intermittent exercise can be just as effective as continuous exercise. So there have been groups out there that have looked at people that work out for an hour straight and people that work out for 3 20-minute sessions that are spread out throughout the day, and they call those bouts. And what they've seen is that there is success in adaptations and there is success at fighting disease when the exercise bouts are above 10 minutes per bout, okay? Very deconditioned people, they can do less than 10 minutes per bout, and you can do, so if you want a deconditioned person to, let's say, do 60 minutes, you can have them do, let's say, 7 sessions at 8 minutes a day throughout the day, okay? Did I say that right? 7 sessions, yeah, 7 sessions at 8 minutes, right? Because someone who's very deconditioned is still going to get benefits from doing something, right? Because something is better than nothing. So with individuals that are healthy and, you know, considered to be healthy, they can do 10-minute sessions a day, right? If we want them to do 90 minutes, they can do 9 10-minute sessions. They can do 3 6-minute or 3 20-minute sessions, which would give you that 60 minutes. So there's different ways that you can kind of change these variables around. But when it comes to deconditioned individuals, if you're going to do bouts, make sure that they're less than 10 minutes a day, okay? And they'll still have favorable adaptations. And then I think this will be the second to the last slide. So let's go through actually, we're going to stop here. This will be the last slide. So when it comes to duration, ACSM says most adults should accumulate 30 to 60 minutes per day, okay, of moderate intensity exercise. 20 to 60 minutes per day of vigorous intensity exercise. A combination of moderate and vigorous intensity exercise can be attained to get that target volume, or you can do them in bouts, okay? They can be done in bouts. Okay, so this is all I have for you guys on duration. We are going to pick up with this same content next week where we'll talk about the other variables. This is just a really long one. And we're going to start talking about HIIT training, where HIIT training is, of course, high intensity interval training. So now we're going to be talking about high intensity training and the duration of that training and the adaptations that come with that training. So this is all I have for you guys. Have a wonderful week, and we will be back next week. Email me if you have any questions about any of those figures in your ACSM manual, and I'll be more than happy to answer them for you. Have a good day.